partial derivatives, Hessian matrix. To get the Hessian matrix, we have to go through the second partial derivative. All right. So again, to get to the Hessian matrix, we have to use the second partial derivative. And to get to the second partial derivative, ladies and gentlemen, we have to go through the first partial derivative. All right. So the first partial derivative, you can look at our previous videos or our previous problems that we solved before when it comes to that, which is the same thing as the gradient. Okay, guys, remember that word? So let's take this function that we saw before when it comes to the first partial derivative of the gradient. So that's f of a b equals to sine of a times sine of b, which is defined over the interval negative pi to pi times negative pi to pi. All right? So now the gradient, which is the answer here, the gradient answer, which is this one, cosine of a times sine of b, and then we have sine of a cosine of b. So this symbol here, that means the first partial derivative of the function with respect to a, and then this one is the first partial derivative of the function f with respect to b. So this one and that one. So we know now the gradient. So because we know the gradient, so now we can go ahead and then find the Hessian matrix, which is the second partial derivative. So let's go for it. All right. So we have and then we're doing it with respect to a. So this is the symbol, okay, of the second partial derivative function with respect to a. All right, again, so that means we're looking at this first partial derivative, okay, and then we're going to find a second partial derivative with respect to a. So with respect to a, that means what? Our target is cosine a. So we're looking at this function here, cosine of a times sine of b, but our target is cosine of a. All right? And then what is the derivative of cosine of a? It's negative sine of a. Correct? And then what are we going to do with the sine of b? Sine of b becomes now a constant. And again, because it's a multiplication between the two of them, so what's going to happen? We will keep the sine of b the way it is. So what does that mean? That means we're having that negative sine of a. Then we bring down the sine b because that now is a constant. So sine of b is now a constant. So we keep it as what it is. And that's it for this one. Okay? Now we're going to continue on the row. All right? And then continuing, that means what? We're going to have so let's see what we're going to have here. So a and then b. So now we're going to find the second partial derivative, again, of this function that we have, where we have the first partial derivative with respect to a and now with respect to b. Okay? So that means we are still here. Ladies and gentlemen, we're still here. The first partial derivative of this function with respect to a, but now because we're going to do it the second time, but we're doing it with b. You guys can see that now, right? So then what are we going to get? So now with respect to b, what's going to happen? So it's sine of b, so that's our target. What's the derivative of sine of b? Is cosine of b. And then what's going to happen to cosine a? Nothing's going to happen to it. It stays just the same because it's the constant here. And then because we have multiplication between the two of them, it stays the same. So it's going to be cosine of a. And then we said this one will be cosine of b because the derivative of sine of b is cosine of b. All right? So as you guys can see on this line here, what do we see here? We have a twice. Then we have a, and then we have b. So that, as you guys can see, so we have a that we have across this row here. So the first horizontal line, the the first row that we have here, we're talking about A. So I usually call it the A row. All right? But then you're not finished because you're dealing with two variables, A and B, so you have to do it also for B. So the second line, the second row, the second horizontal line is going to be for B. So that will be the B line. All right? So how is it the B line? So we have still our symbol. Now we're going to have it, second partial derivative, B, and then we're going to do it with A. So that means what? We're going to take the first partial derivative of the function with respect to B, all right? And now we're going to find the second partial derivative of it with respect to A. So we're here, and now we have to do it with respect to A. So that means what? So that means you have to look at the sign of A here, which is our target. So that's what the A is. And what is the derivative of sine A? It's cosine A. And what are we going to do with the cosine B? Cosine B is just going to be a constant, and then because there's multiplication between the two of them, it stays just the same. So what we're going to have is what? So this one is going to give us what? Cosine of A. And then what's going to happen to cosine of B? It stays just the same. So it's going to be cosine of B. All right? And that's what we have for this one. Now, our next and last, okay, is going to be what? So we're still going to find the second partial derivative of B with respect to B. So because we're going to do it B twice, so we're going to have B squared. And these are the notations. Okay? So that means what? That means we are still over here. The first partial derivative of the function f with respect to B, and then we're going to get the second partial derivative of that same function that we got here with respect to B again. That's the reason why we have it twice. All right, ladies and gentlemen, don't fall asleep on me now. Okay, so what does that mean? So that means we go here, our target is what? Because we're doing it for B again, so our target is cosine B. And what is the derivative of cosine B? Is negative sine B. And what are we going to do with the sine of A? Again, this one will be treated as a constant, and then because there's multiplication, we keep it as a constant. So because we're going to have a negative sign, so we get the negative sign. So I have the sine of A, and then I have sine of B. Okay, so pretty much we are done. So for the Hessian matrix that we have, so for those of you who remember what we talk about when we talk about matrix, okay, so this one is a 2x2 matrix, okay, so it's a 2-row, 2 columns, okay, so 2 rows and then 2 columns, so it's a 2x2 matrix that we have here. So when you have a multivariable function of 2 variables, and then you have to find the Hessian matrix of it already, you should project yourself to know that you'll be getting a 2x2 matrix. All right? So I'm just doing this, little summary so that we now begin to understand what we just did. And then once we get more examples, we're gonna be more acclimated to it. Okay? So as you guys can see, we have on the first row that I call the A row in this case because we're dealing with the variable A. If we're dealing with variable X and Y that we're going to see later on, so that'll be the X line. And then in the second row, we have the B line, okay? So that's what we have, as you guys can see. So you have the A twice, then you have the A first, then the B after that. Then here you have the B, A, and then the B to the square first, okay? So that's what we have for the Hessian matrix. And